Good morning, students. This is Mrs. Sadi Joseph, your science teacher. Welcome back to the online teaching for the session 2020-21. Today, we will start a new chapter, that is chapter 12, Friction. In the previous chapter, we had learned what is force, what are its types, what are the effects of force, etc. Let us have a quick look on this. What is force? Force is a push or a pull which makes a motion in the objects. There are two types of forces, that is conductive force and non-conductive force. Examples for conductive force and non-conductive force also I had explained. Friction is a type of contact force. Let us start our new chapter. You might have seen a driver of a car or a truck slowing down the vehicle at a traffic signal. You to slow down your bicycle whenever needed by applying brakes. Have you ever thought why a vehicle slows down when brakes are applied? When the driver applies a brake on the vehicles, its speed reduces. It slows down. When you apply brakes on your bicycle, it also slows down. Have you ever thought why a vehicle slows down when brakes are applied? Not only vehicles, objects also slows down after some time. What is the reason behind this? Why do we slip when we step on a banana peel? Why is it difficult to walk on a smooth and wet floor? Let us find out the answers to such questions in this chapter. We will do one activity. That is activity number 1 of this chapter. Gently push a book on a table as shown in the figure. You observe that it stops after moving for some distance. When you apply a force on the book, what will happen? It starts moving. After some time, it stops. Repeat this activity, pushing the book from the opposite direction. Does the book stop this time too? Yes, after some time, the motion of the book reduces. It will come to rest. Can you give the reason why it happens so? In the effects of force, we had seen that when you apply a force on an object, it can either increase its speed or reduce the speed. So here also some force may be acting on the book. Which force is acting on the book? Can you say? This force is called the force of friction. So what is force of friction? Force of friction is an opposing force which reduces the motion of the object. The force of friction always opposes the applied force. So it will be always opposite to the direction of force, or we can say opposite to the direction of motion of the object. So you can see that if you apply a force along the left, then friction acts along the right direction, and if you apply the force along the right, the friction acts along the left direction. In both of the cases, the force opposes the motion of the book. So we can say the force of friction always opposes the applied force. The force of friction acts between the two surfaces. So here in this case, the force of friction is acting between the surface of the book and the surface of the table. Is the friction same for all the surfaces? Does it depend on the smoothness of the surface? Let us find out. What are the factors affecting friction? We'll do another activity, that is activity number 2 in your textbook. Tie a string around a brick. Pull the brick by a spring balance. You know what is a spring balance? A spring balance is a device used for measuring the force acting on an object. The force acting on an object is the weight of the object. So we can say spring balance is a device used for measuring the weight of an object. Figure is given in your textbook. Just see that. Now what you have to do? You apply some force on the brick. Then what will happen? The brick will move some distance. Note down the reading on the spring balance when the brick just begins to move. One scale is given on the spring balance and there is a pointer. See the position of the pointer on the scale. That will give the magnitude of the force. So this reading will give you a measure of the force of friction between the surface of the brick and the floor. So here the measure of the force will give you the friction between the surface of the brick and the floor. Now wrap a piece of polythene around the brick and repeat the activity. Do you observe any difference in the readings of the spring balance in the above two cases? Yes, there will be difference in both the cases. Can you give the reason? Because in the first case, friction is more due to the rough surface of the brick. And in the second case, due to the polythene, the friction reduced. So from this activity, we can conclude that the friction is not same for all the surfaces. In smooth surface, less friction is there, and rough surfaces, more friction is there. We'll do another activity. That is activity number 3 in your textbook. Make an inclined plane on a smooth floor or on a table. You may use a wooden board supported by bricks or books, as shown in figure number 4 in your textbook. Put a mark with a pen at any point A on the inclined plane. Now let a pencil cell move down from this point. How far does it move on the table before coming to rest? You have to note down the distance moved by the cell before coming to rest. Now, spread a piece of cloth over the table. Make sure that there are no wrinkles in the cloth. Try the activity again. So, this is an inclined plane. A wooden border supported by some books. It is kept in a slanting position, making an angle with the top of the table. That is called an inclined plane. This is the second case. Repeat this activity by spreading a thin layer of sand over the table. Maintain the same slope throughout the activity. So, 3 different cases are here. First one, inclined plane alone. The second case, a cloth is spread over the table, and in the third case, a thin layer of sand over the table. Can you say in which case is the distance covered the minimum? In case of sand, the distance covered will be the minimum. Why? Why is the distance covered by the pencil cell different every time? So it is because in the case of tabletop alone, because of smooth surface, the friction is less, so the pencil cell can move a long distance. But in the other 2 cases, surfaces are rough, so the friction is more. Because of that, the cell can move less distances. So we can say the friction is not same for all the surfaces. The rough surface have more friction and a smooth surface has less friction. Now, what is the reason for friction? How it is caused? It is caused by the irregularities on the two surfaces in contact. The friction arises when two surfaces come in contact. It is because of the irregularities on the two surfaces friction is caused. Even the surfaces which appear very smooth have a large number of minute irregularities on them. When they come in contact, these irregularities on the surfaces lock into one another. When we attempt to move any surface, we have to apply a force to overcome interlocking. So when these two surfaces come in contact, the irregularities interlock each other. So to overcome this interlocking, we have to apply a force. In case of rough surfaces, there are large number of irregularities, so force of friction is greater. In the case of smooth surfaces, less number of irregularities, so you have to apply less force to overcome that one. In that case, friction is less. Let us have a quick revision of the points which we had learned today. Friction opposes the relative motion between two surfaces in contact. It acts on both the surfaces. Second point, friction depends on the nature of surfaces in contact. Third point, for a given pair surfaces, friction depends upon the state of smoothness of those surfaces. And next point, friction depends on how hard the two surfaces press together. Rest of the chapter we will see in the next video. Till then, thank you, bye bye, and take care.